Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Lecture for grade 9, subject chemistry, chapter number 7, that is electrochemistry. Lecture number 24, and here is Mrs. Saira Jamal. Dear students, in this lecture we will discuss about electroplating. So what is electroplating? The process of coating the surface of a conducting material with a metal is called electroplating. The process of coating the surface of a conducting material means one metal with another metal is called electroplating. Electroplating is usually used to cover a less expensive metal with a more expensive metal, or to cover a corrosive metal with a less corrosive or non-corrosive metal. Now we will discuss the electroplating process on steel. So steel objects are often protected from corrosion by electroplating with zinc, with tin, and with chromium. First of all, we will discuss coating of steel with tin, which is also called tinning. Tinning is the process of thinly coated sheets of wrought iron. Wrought iron means that an alloy of iron which has very less concentration of carbon, or which has very less content of iron, of carbon, or steel with tin, and the resulting product is known as tin plate. Tinning is the process by which a steel is or wrought iron is coated with tin, and the resulting product is called tin plate. The term is also widely used for the different processes of coating a metal with solder before soldering. Solder before soldering means to join parts or to fasten parts is called soldering. Method of tin plating, like how this method will take place. In this method, clean iron or steel sheets are dipped in the bath of molten tin. A layer of tin accumulates on the iron sheet and it gets coated. A layer of tin accumulates on the iron sheet and it's stuck to the iron. This method is based on electrolytic process. An electrolytic cell is developed which contains metals to be tin plated as cathode and pure tin as anode. Dear students, we have learned about the electrolytic process in which the pure metal will be used as the pure metal is used as anode, and the steel or iron which is to be coated is used as a cathode. Reactions involved in tin plating. We will also use some dilute sulfuric acid with electrolyte. The function of this dilute sulfuric acid is that it will prevent hydrolysis. What is hydrolysis? We know that in hydrolysis the water molecules breaks down and then it will react with the reactant substances and will give us some product. We don't want any product. We just want our electrolyte to be in ionized form, and to prevent it from the reaction of that electrolyte with water, we will use this dilute sulfuric acid. This tin sulfate will use as an electrolyte. Aqueous solution of tin sulfate. Tin sulfate in aqueous solution will ionizes into tin ion and sulfate ion. And during the electrolysis process, the following reaction will take place. At anode, the tin will get oxidized by losing 2 electrons and converted into cation. While at cathode, reduction will take place. The tin, after gaining 2 electrons, will get reduced into the metallic tin form or into the solid tin form. Tin plated steel is used to make food canes. You know that almost all the food canes, all types of food canes, they are coated with tin, like the steel is coated with tin to prevent it from corrosion or to prevent it from rusting. So mostly all the food tin canes are coated with tin. The next one is chromium plating. After tin plating on steel, the second one is the chromium plating. So since chromium metal does not adhere strongly to the steel, if we will use directly the chromium or we will dip the steel or iron metal in chromium, so the chromium will not adhere or will stick or will join at the steel surface. So first steel is plated with copper or nickel and then chromium. First the steel or iron is coated with copper or nickel, and then this copper and nickel will help in the adhesion of chromium on the surface of that steel or iron. For electroplating chromium, chromium metal is used as a anode and chromium sulfate is an electrolyte. A few drops of dilute sulfuric acid are added over here, as I told you before, for tin plating, that the function of dilute sulfuric acid is that it will prevent the process of hydrolysis, like the reaction of the electrolyte with water to give us product. We don't want that reaction. We just want our electrolyte in ionized form. So in order to prevent its reaction with water, we will use dilute sulfuric acid. As I told you that this pure chromium we will use as a anode, and the steel or iron which is going to be electroplate, we will use it as a cathode. So the electrolyte ionizes as follows. This is our electrolyte. Chromium sulfate is an electrolyte. It will ionize. It will not react with water because we are making aqueous solution. And in aqueous solution, this electrolyte will ionize to give us chromium ion and sulfate ion. The chromium sulfate in aqueous solution means in water will give us chromium ion and sulfate ion. I told you that we will add dilute sulfuric acid for the purpose to prevent the reaction of this chromium sulfate with water to give us some other product. So do you agree that the following reaction will occur at the electrode? As I told you that the pure chromium will use as an anode, and the steel or iron which we are going to electroplate it will use as a cathode. So at anode, the chromium will get oxidized by losing 3 electrons and will form chromium trivalent cation. And at cathode, this chromium trivalent cation will gain electrons and will convert it into the metallic form or chromium form, which will deposit at the cathode and then in turn will electroplate that iron or steel. Chromium plated steel is used to make automobile parts. You know that most of the automobile parts, they are made up of chromium. So you can see here in this image, the motorbike, all the parts of the motorbike, they are made up of the iron or steel, but which type of steel? Chromium plated steel. In this case also, in the parts of all types of automobiles, the steel which is used is chromium plated. Next topic is the corrosion and its prevention. So first of all, we must know that what is meant by corrosion. Corrosion is a process in which a metal reacts with oxygen and moisture in the atmosphere. You know that air is composed of oxygen and also water vapors are present in air. So we can say that when the metal, we expose it in atmosphere for a long time, what will happen, that metal will react with the oxygen and water vapors in the atmosphere and then corrode it. Corrosion is a natural process that converts a refined metal, a pure metal, into a more chemically stable form, such as if we have suppose iron, you can see in this image. If we have iron pipes, and you can see these iron pipes are corroded now, they have rust on it, and rust are type of salts which are stable form of iron, and they are stable because then they will further not react to form any other thing. So they will remain like the iron will convert it into the stable form, that is the iron oxide. So so over here they say that the stable form of any metal are oxides of that metal, maybe iron oxide or aluminium oxide or chromium oxide, and a hydroxide of iron hydroxide or aluminum hydroxide, or sulfide, iron sulfide, aluminum sulfide. So these oxides of the metal, hydroxides of the metal, or sulfide of the metal, they are more stable than the pure or the metallic form of iron or metallic form of the aluminum. So it is the gradual destruction of material by chemical or electrochemical reaction with their environment. Means the metal react with the oxygen and water vapors in the environment, and then what will happen? The destruction of that material takes place. You can see in this image that the metal is almost destructed. Examples of corrosion are, the first one is rusting of iron. So rust, what is rust? You can see in this image the iron which got rusted, and rust is an iron oxide. Like what is rust? The formula of rust is iron oxide, and usually reddish brown oxide. You can see in this image they are reddish brown oxides formed by the reaction of iron and oxygen in the presence of water or air moisture. Water vapors or water, if directly come in contact with water, if we will place the metal in water for a long time, or even the water vapors which are present in the atmosphere. So the iron will react with that oxygen or with the water vapors or with water to form rust. And what is rust? Iron oxide. Iron oxide is called rust. So a region of metal which has more moisture or more water will act as a cathode, and area with less moisture will act as a anode. Now we will study the chemistry of the rusting process. Actually, what happened during the rusting process. Stains and dents on the surface of the iron provide the sites for this process to occur. If there is any dent or any stain on iron, maybe an iron nail or an iron bar or iron chair, whatever object is, but that object is made up of iron. So if any stain occur on that iron or any dent on that iron, it will provide the site for this process. Like that process will first actually will affected by reaction with moisture or with oxygen in air. This region is called anodic region because it has less content or less percentage or less concentration of water. I told you the region of metal which has less moisture or less contact with moisture will act as an anode. And what will happen to that iron at anode? Actually, oxidation will take place at anode because I told you oxidation always takes place at anode. So iron get oxidized by losing 4 electrons. One iron is losing 2 electrons. So here we have 2 iron. So per iron, 2 electrons. So for 2 iron, will loses 4 electrons. So iron, 2 iron will get oxidized by losing 4 electrons. This loss of electrons damage the object. The free electrons move through an iron through iron sheet, to that iron sheet or iron nail or iron bar, whatever is the object. So these electrons will then move freely move in that object until they reach to a region of relatively high oxygen concentration near the surface surrounded by water layer as shown in figure. You know that when that electrons will move, they will reach to the surface of the iron where there is more moisture, because atmosphere has moisture over there, or even some water drops are present at the surface of the iron. So that area of the metal which has more concentration of water will act as a cathode. And I told you that at cathode reduction takes place. So oxygen from the atmosphere and hydrogen in water will take those 4 electrons and will convert it into 2 moles of water. So water will form at the cathode. At the cathode, what happened? Reduction of the oxygen takes place, and that oxygen will gain electrons, 4 electrons, and will convert it into water. Dear student, you can see in this image that this gray color is iron, an object, iron bar, and this iron bar, this internal surface of this iron will act as an anode. And at anode, I told you the iron will get oxidized by losing 2 electrons. Per iron is losing 2 electrons, and if there is 2 iron, then it will give 4 electrons. So in the previous case, I told you 4 electrons for 2 moles of iron, and over here it is mentioned only 1 iron, so 1 iron will loses 2 electrons. So iron at anode will get oxidized by losing 2 electrons, and the iron which is close to the atmosphere, the surface of the iron which is close to the atmosphere, you can see here water droplets are there or water vapors are there. So that iron will react like the electrons which are lost by the iron, which will act as an anode. Those electrons I told you will freely move and will reach at the surface, and those electrons will then gain by the oxygen from the atmosphere, and that oxygen and also water is present, or water content is present. So that oxygen, after gaining those 4 electrons lost by the iron, and will convert it into the hydroxides, and that 4 hydroxide you can also write it as water. You can write it 4 hydroxide ion, or you can also write it as 2 water molecules. Both are same. Okay, so they will give us the water, and you can see these hydroxide ions or water and these iron, ferrous iron, will react together to form ferric oxide with X water molecule. X means the number of water molecules vary with the surrounding moisture. So there may be 2 water molecules, 4, 6, whatever. The water molecules, the number of water molecules vary. But this is actually the formula of rust, and you can see this brownish material at the surface of the iron, which is called rust. So the hydrogen ions which are present, or with which the oxygen react, you can see oxygen not only take 4 electrons lost by the 2 iron ions or the 2 iron metal, but also will react with the protons. From where these protons came? So these protons came from or these photons are provided by the carbonic acid. You know that the normal water contain carbon dioxide dissolved in it, and that acid and will form acid. That acid is called carbonic acid. The normal rainwater contain carbonic acid in it, and that's why the pH of water is 5.6 normal rain, which is formed because of the presence of carbon dioxide in water. That is why this acid will give acidic medium for the reaction. So in acidic medium, the process of rusting accelerate or speeds up. So the overall redox process is completely completed without the formation of rust. Like if we say that uh, there is no rust now, but when iron react with solid iron, react with the oxygen of the atmosphere and water which is present and hydrogen proton which is present in water, will give us 2 moles of iron ion or ferrous ion and 2 moles of water. So this ferrous ion form spreads throughout the surrounding water and then react with oxygen of the atmosphere to form the salt. which is called ferric oxide with N or X water molecule, and which is called rust. So this is the formula of rust. If you will write X here or N here, no problem, they are same. It is also a redox reaction. So the iron which is formed at anode, I told you, will also, the electron will also move, and the ion will also move, and it will reach to the surface, or will reach towards the cathode, and then at the surface or at the cathode, this iron will react with the oxygen from the atmosphere, because you can see here gas, that is oxygen from the atmosphere. Aqueous means iron which is present or which is oxidized at anode will react, and also water vapors are also present. So iron will react with the atmospheric oxygen and also with the water vapors to form ferric oxide with N moles or with X moles of water, and this proton will evolve out or will eject out. So this proton can accelerate the formation of another molecule of rust. So this will help in rusting. The rust layer of iron is porous. Porous means it has holes and does not prevent further corrosion. And what will happen once the iron get corroded? So this process will continue until all the iron object or iron piece is eaten up, or it will destroyed by the this corrosion process. Next one is corrosion of aluminum. So corrosion is not limited to iron. Like iron is not only the metal which got corroded. The other metals, they may also corroded. So corrosion is not only limited to iron. Aluminum is extensively used in the construction of aircrafts, ships, cars, cooking utensils, window frames, soda cans. Why we are using aluminum? One of the reason is that it is highly stable. Oxide of aluminum actually is highly stable. And a second reason is it is the lighter metal or the lightest metal. So due to the property of light in weight, it is mostly used in aluminum foils and also in aircrafts. So aluminum has much higher tendency to oxidize than iron. Like if there is a competition between iron and aluminum to get oxidized, so aluminum, the rate of oxidation of aluminum will be higher than that of iron. So therefore, we might expect to see aircraft, ships, cars, cooking utensils, soda cans transformed into piles of corroded aluminum. They can also get corroded. However, this does not occur like this is because a tough layer of insoluble aluminum oxide forms on its surface. Over here, they said that like same like the iron, like most of the iron objects, they are corroded. But like we would expect to see these objects which are made up of aluminum in the corroded form, but this does not occur. The reason is that the layer of aluminum oxide which is formed on the surface of aluminum metal, it is highly stable, it is highly tough layer, a hard layer, and it will not allow the aluminum which is present inside that layer to get corroded. In case of iron, I told you the layer is porous. So the water content in the atmosphere, like the first layer will wash out, and then the internal part of the iron will get exposed, and then rusting process will continue. But in case of the aluminum, the layer which is formed on aluminum, which is aluminum oxide, it is a tough layer, a hard layer formed on surface. And when metal is exposed to air, this layer firmly adheres to the metal and serves to protect the underlying aluminum layers from further corrosion. So the upper layer will prevent the lower layers from corrosion. On the other hand, the insoluble layer of iron, which is the rust, this rust layer which is formed, iron oxide layer which is formed, this rusting layer is, I told you, porous, and that forms on the surface of iron is too porous to protect the underlying metal. So that's why this layer flakes away or washed away and exposes the inner metal, internal metal for further corrosion. That's why the process of corrosion will continue until all the aluminum will get corroded. You can see here in this image, dear student, the corroded aluminum. This is the sink, which is made up of aluminum, and it get corroded. So this is the corroded aluminum sinks. And I told you mostly it is rare because the upper layer is corroded, but the lower layer will be safe from corrosion due to this tough layer of aluminum which is formed at the top of that object which is made up of aluminum. So dear students, I hope you will understand this lecture. Inshallah, the prevention from corrosion and exercise of this chapter number 7 we will do in our next lecture. Till then, take care. Allah.